Good morning, girls. Today I'm starting a new chapter, that is Unit 7 P-Block Elements. Unit 7 P-Block Elements. Last year we had already which one? Periodic table, that we brief description about SP block elements it was there. But here it is the detailed explanation of P-block elements, and it is a very easy chapter, but it is a lengthy chapter and the compulsory questions are also there from this chapter, and it is having 10 marks. Okay, so all of you know P block means what? If you are considering this is as the periodic table, this left side it was which one? S block elements, right? S block elements means which one? Our hydrogen, lithium, sodium, potassium, then magnesium, beryllium, magnesium, etc. were S block, and the middle it was D block elements were there, and the right side we know it is where which one? P block. So P block means it is from group 13 to 18. We know total 18 groups are there in the periodic table. In that group 13 to 18 is which one? P block elements. Okay, so the P block elements generally they are having the electronic configuration ns2 np126. What is the general electronic configuration? ns2 np126. Okay, that means s orbital is completely filled and the p orbital can 1 electron, 2 electron, 3 electron, etc. depending upon the which group they are. Okay, then but except we know helium also in the 18th group is helium, neon, argon, krypton, xenon, that is also included in P block. That is our noble gases. But helium is having the electronic configuration 1s2. Okay. This year question paper they asked, I think, an element in P block having the electronic configuration 1s2. Which element is that one? Which one is that? Helium. Okay. All others are having ns2. S orbital also there, and which one is there? P orbital is there. Okay. So they are having the general electronic configuration ns2 np126, but helium is having only 1s2, and the group 13 to 8 is known as which one? Our P block elements. And in P block it is containing non-metals, means gas is there, gas molecules are there, then metals are there, and metalloids are there. Metalloids means semiconductors. Metalloids means semiconductors. We know germanium, silicon, etc. it is coming in. I will explain detail. Okay, so generally P block elements containing metals, non-metals, and metalloids. Metalloids means which one? Semiconductors. Okay, so that is the just introduction about P block elements. Next we are moving to which one? Our main P block element, main group in P block. Okay, in your syllabus it is starting from group 15. Okay, 13 and 14 is not there. Okay, which one it is starting? It is starting from group 15, and group 15 is known as which one? Nitrogen family. Which family it is? Nitrogen family, and that family is having one more name, that is known as which one? Nitrogens. What is the name? They can ask one more question. What is the other name for P block element? What is the other name for nitrogen family? What is the other name? Nitrogens. P is silent here. P-N-I-C-T-O-G-E-N-S. That is known as nitrogens. Okay, so group 15 nitrogen family we have to study first in detail. We know what are the members of nitrogen family. Nitrogen family means mainly first one is which one? Nitrogen, then phosphorus, then arsenic, then antimony, Sb, and which one is there? Bismuth, Bi. Okay, so nitrogen, phosphorus. Nitrogen family means first member will be which one? Nitrogen. So nitrogen, phosphorus, arsenic, As, Sb, antimony, and Bi means which one? Bismuth. So these are the members in which family? Nitrogen family. Clear? Nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. And next is their occurrence. It is not very important, just I am telling. Occurrence means nitrogen is the which one? Most abundant element in where? Atmosphere. 78% is which one is containing in the atmosphere? It is nitrogen. Okay, and nitrogen is mainly found in the form of which one? Sodium nitrate. That is which one? Chili saltpeter. In the form of nitrogen is found mainly in the form of sodium nitrate. That is chili saltpeter. And potassium nitrate, that is known as what? Indian saltpeter. Potassium nitrate, that is known as Indian saltpeter. So in atmosphere, 78% is which one is there? Nitrogen is there. And nitrogen is mainly found as in earth crust as sodium nitrate and potassium nitrate. Sodium nitrate is known as what? Chili saltpeter, and the potassium nitrate is known as which one? Indian saltpeter. And nitrogen is also found in which one? Proteins. Okay, proteins, etc. Next one is, so that is about nitrogen, 78 most abundant element in the atmosphere. Okay. Next is we are moving to phosphorus. Phosphorus means it is the 11th. Phosphorus means it is the 11th element in earth crust. Okay. Since nitrogen is the most abundant element in the atmosphere, gas in the atmosphere, and phosphorus is the 11th element in which one? The earth crust. Okay. And this phosphorus is generally found in the form of which one? Apatite. It is mainly found in which one? Rocks. Phosphorus is mainly found in which one? Rocks, and it is mainly found in rocks in the form of apatite. Okay, so having the general formula Ca9 PO4 6 times dot CaX2. Okay, so generally phosphorus is found in which one? Rocks in the form of apatite. Okay, so apatite means that they are having the general formula Ca9 PO4 6 times CaX2. Their X may be halogens. X may be chlorine, fluorine and bromine. Okay, so fluoroapatite, FeLuoro apatite. Fluoroapatite means how we can write the formula Ca9 PO4 6 times. Here not change. Only what will be changed? The X will be changed. Here fluorine means what will be? X. It will be fluorine. Okay. CaF2. Okay. So that is known as fluoroapatite. If it is chloroapatite means what we will change? In the place of X we will write halogens. Okay. So phosphorus is the 11th abundant element in the earth crust, and it is found in rocks in the form of apatite, having the general formula Ca9 PO4 6 times CaX2. For example, fluoroapatite means it is having the formula Ca9 PO4 6 times CaF2, and it is also found in, it is a main component in which one? Animals and plants. Okay, and phosphoproteins are found in which one? Milk. That is, it is found in bone. We know, all of you know, phosphorus and calcium, it is found in bones, etc. That is about which one? Phosphorus. And next, which one is coming? Arsenic, antimony and bismuth. They are not very abundant in the earth. Okay, and they are mainly found in the form of which ores? Sulfide ores. They are mainly found in which one? Sulfide ores. Okay, so group 15, that is known as nitrogen family. Nitrogen family is also known as nitrogens. What are the members of this family? Nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, next we are moving to the electronic configuration of this family members. What is the electronic configuration of nitrogen family? We know NS2 NP1 to 6 was the general electronic configuration for the P-block elements. So what is the general electronic configuration for which one? Nitrogen family. Nitrogen family is having the general electronic configuration NS2. Electronic configuration easy I am writing. Okay, NS2 NP3. NS2 NP3. So what is the general electronic configuration? Outer electronic configuration. Okay, general outer electronic configuration of nitrogen family NS2 NP3. So S orbital is completely filled and the P orbital is which one? Half filled. Clear? So first we are writing the, due to this half filled orbital for P orbital, they are having which one? Extra stability. If it is half filled, we know D 10 is there. If it is 5, half filled. If it is half filled means they will have extra stability. Last year I explained you. So here also for P, maximum 6 electrons we can accommodate. But here for nitrogen family it is P3 is having maximum. So they are having which one? Half filled orbital. So it is having an extra stability. So general electronic configuration is NS2 NP3. Okay. So, first we are writing the electronic configuration of which one? Nitrogen. We know for writing, for easy writing, we will take, first we will write which one? Noble gas. Then the outer electronic configuration we will writing. Okay, so first we know nitrogen. Nitrogen means what? 7. So 7 means how we will write nitrogen? 7 means we can write 1s2, 2s2, 2p3. 3 plus 2, 5 plus 2, 7. Atomic number is 7. But instead of writing 1s2, we can write which one? Helium. Because helium is having electronic configuration 1s2. So, helium 2s2, 2p3. Why it is which one? 2 it is coming. We know it is in which period it is coming. It is in second period. Okay. So, the number will be which one? The ns2 means n equal to the number of period. Which period it is coming? Okay. It is coming in the second period. So, that is why it is 2s2, 2p3. Clear? Everything I explained last year. So the electronic configuration is NS2 helium 2s2 2p3. Next is nitrogen is atomic number 7. Next phosphorus is having atomic number 15. And the electronic configuration is neon 3s2 3p3. Why it is coming 3? 3 means what? It is coming in which period? Third period. Okay. Next member is what? Nitrogen, phosphorus, arsenic. Arsenic is having atomic number 33 and the electronic configuration is argon 3d10 4s2 4p3. So you can see if you are checking everywhere the outer thing is which one, which orbital is there, in each case p orbital. Even here arsenic d orbital is there, but the outer electrons are going to which orbital? P orbital. That is why it is known as which one? P block elements. S orbital means S block elements means the outer electron will go to S orbital. Last electrons. P block elements means the last electrons will go to P orbital. D block means what? The last electron will go to the valence electron will go to the D orbital. Okay. So nitrogen, phosphorus, arsenic. Then which one is coming? This one, Sb. Sb means what? Antimony. What is it? Antimony. As means what? Arsenic. And Sb means which one? Antimony. Okay. Antimony is having atomic number 51 and it is krypton 4d10 5s2 5p3. Why it is 5 here? Because it in which period? Fifth period. Okay. So it is very easy, girls, to learn the electronic configuration. Nitrogen second period, so 2s2 2p3. Phosphorus third period, that is why 3s2 3p3. Arsenic fourth, so 4s2 4p3. Antimony which one? Fifth first, 5s2 5p3. Okay. Last member is bismuth and it is having the atomic number 83. So it is xenon 4f14 d10 6s2 6p3. Okay. So it is including f orbital and d orbital. But the outer electrons are going to which one? P orbital. And which period it is coming? Sixth period. Okay. No need of by hearting the electronic configuration. Okay. So nitrogen means it is 2s2 2p3. Then phosphorus means 3s2 3p3. Then arsenic means which one? 5s2 4s2 4p3. Then which one is coming? Antimony means 5s2 5p3. And which one? Last one, bismuth means which is 6s2 6p3. 6, that outer number, this number is representing which one? The which period they are belonging to. So general electronic configuration is ns2 np3. That means the last electrons are going to which one? P orbital. Due to the half-filled orbital, P orbital, they are having extra stability. And if you are checking the elements in this family, nitrogen is there. First one is nitrogen and phosphorus, right? Okay. So nitrogen and phosphorus is which one? Non-metals. Nitrogen and phosphorus is non-metal. Okay. Then arsenic and antimony is known as metalloids or semiconductors. They are arsenic and antimony is which one? Metalloid or semiconductors. And bismuth is only which one? Metal. Okay. So in nitrogen family, nitrogen and phosphorus is which one? Non-metals. We know nitrogen is a gas. Then arsenic and antimony is which one? Metalloid or Semiconductors. Metalloid means what? It is having both the character of metals and non-metals. Then bismuth is only metal in this family. So that is which one? The electronic configuration. Next we are moving to the atomic radius or ionic radius. Atomic radius or ionic radius. All of you know how it will be. The atomic radius and ionic radius will vary along the group and along the period. We discussed very detailed in last year. Okay. So if we are taking nitrogen family, how we will write nitrogen? First one is atomic and ionic radius. And ionic radius. Atomic and ionic radius. So if we are considering this one, nitrogen, phosphorus, arsenic, antimony and bismuth. I have to write the names. N means nitrogen, P means phosphorus, arsenic As and antimony means Sb and bismuth Bi. Okay. So if you are moving down, we know along the down the group atomic radius what will happen? Increases because additional shells, we are adding shells. So atomic radius increases. Okay. So around the group, down the group atomic radius increases. Generally down the group atomic radius increases and along the period what will happen? Atomic radius decreases. So here in nitrogen family down the group what is happening? The atomic radius increases. So which one is the smallest member in this family? Nitrogen. Okay. Then second thing is ionization energy. Ionization energy means what? We know that is last year. Ionization energy or I we can represent. Okay. Ionization energy, IH. Ionization enthalpy, IH. What is ionization energy? It is the energy required to remove an electron from the outermost shell. Okay. So we know if the size increases means what will happen? The very easy to remove the outermost electron because the nuclear force of attraction, the attraction between the nucleus and outermost electron will be very less. So it is very easy to remove the electron from the outermost cell. So if you are considering the ionization energy down the group, what will happen? Down the group sizes increases. Down the group sizes increases. So it is very easy to remove the outermost electron. So ionization energy decreases. So atomic radius increases. First one is atomic radius increases. But ionization energy what is happening? Decreases down the group. Okay. But if you are comparing the 14th group and 15th group, this is 15th group. Okay. So 14th group means it will come here. If you are considering the 14th group and 15th group, which one will have highest ionization energy? We know if you are moving from left to right along the period what is happening? Atomic radius decreases. So that is why ionization energy increases. So compared to group 14, group 15 is having higher ionization energy due to what is happening? Due to the half-filled p orbital. We know in nitrogen family the electrons are going to, the p3 is the valence shell electron configuration. So it is what? Half filled. So it is having an extra stability. So it is not easy to remove the electrons compared to which one? Group 14. Okay. So compared to group 14, group 15 elements are having higher ionization energy due to the extra stable half-filled p orbital. Okay. So atomic radius or ionic radius, generally it is they are forming covalent compounds. So we can call it as covalent radius. Okay. It will increases down the group. Ionization energy decreases down the group. But if you compare to group 14, group 15 elements are having higher ionization energy due to extra stability of half-filled p orbital. Okay. Then there is an order of ionization energy. First ionization energy, then second ionization energy and third ionization energy. Okay. So this is the energy. First ionization energy means it is the energy required to remove the first electron. It is less than the energy required to remove the second electron. And which one is having the energy more? The third electron. For removing the third electron, we have to supply more energy. Why? Because it is a P3 is having extra stability because of half-filled orbitals. Okay. So the order of ionization energy, first ionization energy means to remove the first electron. From P or 3 electrons are there. Okay. To remove the first electron, it is very easy. Less energy, then little more energy we have to supply for to remove the second electron. Then the third electron for removing the third electron we have to supply the more energy. So what is the order? This is the order. Okay. The next property is coming, electronegativity. Electronegativity means what? It is the ability to attract electrons. Okay. So electronegativity, we know which one is the highest electronegative element in the periodic table. Fluorine, it is having 4. But if you are comparing the nitrogen family is having which one? High electronegativity value, and the electronegativity value decreases down the group. Electronegativity value, what is happening? Electronegativity value decreases down the group. So general properties now I told you what is electronic configuration, general electronic configuration, then atomic radius, then ionization energy, and which one? Electronegativity. Okay. So atomic radius increases down the group. Okay. Ionization energy decreases down the group, but compared to group 15 is having higher ionization energy due to extra stability of P3, half-filled P3 orbitals. Okay. And electronegativity. So nitrogen family is having higher electronegativity, but electronegativity value decreases down the group. So clear all of you, that is the general properties. Next is the physical properties of nitrogen family. Physical properties means the members of the nitrogen family is polyatomic except which one? Nitrogen. We know nitrogen means it is N2, right? N2 means it is a diatomic gas. All others are existing. It is a polyatomic. P4 etc. is there. Okay, so it is all elements in nitrogen family is polyatomic except nitrogen. Nitrogen is a diatomic molecule. Okay, and if you are taking which one? It's electronegativity. Electronegativity decreases down the group. Then it is containing this group containing metals, metalloids, and non-metals. Non-metals, metalloids, and which one is there? Semiconductors, that is metals, non-metals, and metalloids are there. Metalloids means what? It is semiconductors. Okay. Then which one? Most of the metals, most of the elements in this family exist allotropy. Allotropy means what? Allotropy. Okay. Allotropy means what? Existing in different forms. For example, carbon is having diamond and graphite. Okay. So all the members in this family showing allotropy except which one? Nitrogen. Except which one? Nitrogen. And if you are considering the melting point and all, what will happen? It will increases down the group. Okay. So that is generally about the physical properties. Clearly I will give you the notes. It is not very much important. Next, we are moving to the oxidation states and trends in chemical reactivity. So, oxidation state we will see. Okay. Generally, the common oxidation state of this family is +3, +5 and -3. So, what is the common oxidation state of nitrogen family? It is +3, +5 and -3. Okay. So, we can see here positive oxidation state is also there. Which one is there? The negative oxidation state is there. So, positive oxidation state is mainly they show +3 and +5 oxidation state. Okay. So +3 oxidation state, if you are moving down the group, the stability of +3 oxidation state increases. Okay. Due to inert pair effect. What is the term here? Inert pair effect. Inert pair effect means it is the ability of outermost s orbitals do not undergoing sharing. That means that s orbital is having here 2 electrons. No, because it is having they are having the general electronic configuration ns2 np3. That s orbital 2 electrons are there that will exist as an inert. That means that they will not undergo any sharing. Okay. So if you are moving down the group, that 2 electrons in the s orbital will be remain same. So that is why there is a tendency to show the +3 oxidation state. Okay. So the stability of +3 oxidation state increases down the group. Okay. But the +5 oxidation state decreases down the group, and only bismuth is forming a +5 compound. That is well-known compound is bismuth pentafluoride. In this case, bismuth is having which one? +5 oxidation state. Okay. So nitrogen can form +1, +2, +4, +3, etc. oxidation state. So +1 is there, +2 is there, +4 also there. The common oxidation state of this group is +3 and +5 and -3. Okay. Next is negative oxidation state. Nitrogen is having -3 oxidation state due to its high electronegativity. Nitrogen is showing -3 oxidation state due to its high electronegativity. Okay, so we know that which one the nitrogen can form +1, +2, that this negative oxidation state, the tendency to form the negative oxidation state decreases down the group. Why it is decreasing means because of decreasing electronegativity. Okay, so nitrogen is forming -3 oxidation state due to its high electronegativity, but this -3 oxidation state, if you are moving down, it is decreases. Stability of -3 oxidation decreases due to decreasing electronegativity. Okay, so we know, I already told you, nitrogen is having +1, +2, +4. This oxidation state from +1 to +4, it will undergo disproportionation in which medium? Acidic medium. Disproportionation means one oxidation state will be converted to other oxidation states. So for example, here HNO3, it is an acidic solution. So here it was nitrogen +3, it is converted to +5 and it is converted to +2. So the positive oxidation states of the nitrogen from +1, +2, +4, etc. will undergo which one? Disproportionation in which medium? Acidic medium. Disproportionation means what? Changing the oxidation state from one to other. That is from +3 to +5 and +2. Okay. Then phosphorus is having generally +1 and +4 oxidation states in their oxo acids. Oxo acids means oxygen containing acids are known as oxo acids. For example, we know phosphorus is H3PO4. It is an oxo acid of phosphorus. Why it is an oxo acid? Because it is containing oxygen. Detailed study of oxo acids is coming later in this chapter. Okay. So phosphorus is showing +1 and +4 oxidation state in their oxo acids. Okay. Then arsenic, other members like our which one? Arsenic, bismuth and antimony, etc. is showing +3 oxidation states also they are showing. Then one more point in the oxidation states is nitrogen is having covalency. Maximum covalency is 4. Covalency means how many bonds it can form. Okay. Nitrogen can form maximum 4 bonds. The covalency of nitrogen is limited to 4. What is the reason is, we know if you are taking nitrogen, what is electronic configuration? Outer electronic configuration 2s2 2p3. Right. So how many orbitals are available for nitrogen? This is 1 s orbital and which one? 3 p orbitals. Here s orbital is there. Okay. Then how many p orbitals are available? Only 3 p orbitals are available. This is 1s2. This is 2s2 means this is only s orbital, and p means how many which is available? 3. S is 1 only. No. S is 1 only, girls. In one orbital only 2 electrons. So 1 s orbital, and how many p orbitals are there? 3 p orbitals. So 4 orbitals are available only in case of nitrogen. That is why the covalency is limited to 4 in case of nitrogen. One reason is what? It is having maximum 4 orbitals. That is 1 s orbital, and 1 s means 1 s. Okay. And 3 p orbitals. So that is why one reason it is having only 4 orbital, 1 s orbital and 3 p orbital. And the second reason is non-availability of d orbital. If you are checking nitrogen, it is not having d orbital. So its covalency is limited to 4. That means it can form maximum 4 bonds. Okay. But if you are taking phosphorus and all, they are, if other members, if you are considering other members, they will have which one? D orbital. Availability of d orbitals is there in the in their last availability of d orbital is there. That is why their covalence is extended more than 4 due to the presence of which one? D orbital. Availability of, due to the availability of d orbital, the covalency of other members of this family is extended more than 4. But nitrogen is having covalency 4 due to one reason. It is 1s and 3p orbitals. So total 4 orbitals are available, and the second reason is non-availability of d orbitals. So that is about which one? The oxidation state. Okay, so which one is the common oxidation state? +3, +5 and -3. Next is very important topic, that is nitrogen is having some anomalous behavior from its family. That means nitrogen is the first member in nitrogen family. It is showing some anomalous behavior from the other members of family. Okay, what are the reasons for this? So the question they will ask minimum 3 reasons you have to learn. It is very easy. Okay, so the reasons for the anomalous behavior of nitrogen or the anomalous behavior of nitrogen is due to, what are the reasons? Okay, so first reason is which one? Small in size. We know it is nitrogen is the first member in the family, so size will be small. Then second one is high electronegativity. Nitrogen is having high electronegativity, then small size, then high ionization energy, then non-availability of d orbitals, and formation of p-pi multiple bond. That means the p orbitals in the nitrogen will undergo sideways overlapping and form double bond. Actually nitrogen is having n triple bond, and so here we can see multiple bonds are there. It is due to the p-pi orbital overlapping. Okay, so formation of p-pi multiple bond. So what are the reasons? 5 reasons are there for the anomalous behavior of nitrogen is small in size, high electronegativity, high ionization energy, non-availability of vacant d orbital, and formation of p-pi multiple bonding. Okay, then next it is, what are the differences it is showing from the other members of the family? The difference is due to these reasons. Then you have to, they will ask any 3 difference of nitrogen from other members. Okay, so many reasons are, many differences are given in your, which one, in your syllabus or in your textbook. So you have to know what are the differences from the other members of the family. That is also minimum 3 they will ask. First difference is, we know nitrogen is a gas molecule, but others are which one? Solids. Okay, and nitrogen is a diatomic. Nitrogen is exists as which one? N2, but others are which one? Tetra, polyatomic I told. For example, phosphorus is a tetraatomic and arsenic is also As4P4, but nitrogen is N2. Then next is nitrogen, it is forming a triple bond. That is why it is having n triple bond N. That is why the bond enthalpy is high. The energy required to break the bond. Okay, but others form which one? P for single bond. For example, PP single bond. Arsenic also which one it will form? It will form a single bond. Okay, bismuth is forming metallic bond. Then nitrogen can form how many oxides? 5 oxides. NO, N2O3, N2O4, N2O5. But other members are forming maximum 2 oxides. Okay. Then hydrides of nitrogen form hydrogen bonding. For example, NH3 is a hydride of which one? Ammonia is a hydride of nitrogen. It can have the ability to form which one? Hydrogen bonding. Hydrogen bonding means this nitrogen next to NH3 means this is the next NH3. So this nitrogen can form a bond with the hydrogen of the next molecule. You know that. Okay, hydrogen bonding means. So the hydrides of nitrogen form hydrogen bonding. Okay, and we know the nitrogen is having maximum covalency 4. So it is not having a penta covalency due to the absence of d orbital. Then it will not form complexes due to the absence of d orbital. One more questions you can expect here. Nitrogen is not having penta covalency. What is the reason? It is due to the absence of d orbital. Okay, then it does not form complexes. It is due to the absence of d orbital. Then Now, hydrates of nitrogen. We know nitrogen. The hydrate of nitrogen example just now I told you ammonia. Ammonia. Okay. It is highly basic. We know ammonia is a basic compound. Okay. So the hydrates of nitrogen is basic, highly basic. But other members hydrates are not highly basic. Okay. Then nitrogen fluoride NF3 is stable. Okay. But others NCl3 halides of nitrogen like NF3 is stable. But others like NCl3, NBr3 etc. is unstable. But other members, all the halides are which one? Stable like PCl3, PCl5 etc. all are stable. Okay, but nitrogen, in case of nitrogen only fluoride halide is stable but others are unstable. So many differences are from the members. This is very important. What is very important? The anomalous behavior of the nitrogen from the other members of the families due to reasons. Then what are the main point of differences? First one is nitrogen is a gas but others are solid. Okay. Then nitrogen is diatomic but others are tetraatomic. Then nitrogen triple bond is there, that's why bond enthalpy is more, but others are having single bond. Then nitrogen is forming 5 oxides but others are forming maximum 2 oxides. Then hydrates form of nitrogen form hydrogen bonding. Then nitrogen cannot form penta covalency due to the absence of which one d orbital, and nitrogen cannot form complexes due to the absence of d orbital. And then which one? The hydrates of nitrogen that like ammonia is highly basic. Then the halides of nitrogen only NF3 is stable but others are unstable. So that is about today's class. Clear all of you?